Bright QT. Every student matters.
Hello students, now let's solve the questions for this portion of the exercise. The first question is, why is the conversion of ethanol to ethanoic an oxidation reaction? Now ethanol gets converted to ethanoic acid when you add an oxidizing agent and heat. It takes oxygen from the environment and there's an oxygen which gets added. So the structure of ethanol, which looks like this, these hydrogen get removed, and instead of it there's a double bond O that gets here. So because oxygen is being added in this process is called as an oxidation reaction. The mixture of oxygen and ethine is burnt for welding. Can you tell why the mixture of ethine and air is not used? So why is it that we prefer to use oxygen and not air? Is because that when we burn ethine with air, incomplete combustion takes place, which does not produce enough heat and also leaves behind soot. Rather, the better form would be if we use pure oxygen, and then complete combustion would be possible, which would release ample amount of heat and it would burn with a clear flame. That is why for welding, ethine is burnt with oxygen and not with air. While cooking, if the bottom of the vessel is getting blackened out on the outside, it means that the food is not cooked completely, the fuel is not burnt completely, the fuel is wet, or the fuel is burning completely. Now, when soot is being deposited under a vessel from the fire that is lit, it implies a simple thing that proper burning of this fuel is not happening, and that is why, because of incomplete burning, soot gets deposited on the surface of the utensils, which turns it into black. So the fuel is not being burned completely is the correct answer here. Why are the carbon and its compounds used as fuels for most applications? So carbon compounds undergo the reaction of combustion. When they undergo combustion, they produce a large amount of heat, and this heat can be used to produce can be used in different ways. So because of its high calorific value, and because saturated hydrocarbons even burn with a clear flame and do not deposit soot, they are used as fuels in a lot of industries. What is hydrogenation and what are its industrial applications? So hydrogenation is the process wherein in an unsaturated hydrocarbon, the double bond breaks and hydrogen gets added on each carbon. So it's a process of unsaturated hydrocarbon, be it double or triple bond, which reacts with hydrogen in the presence of catalyst of nickel or cadmium, and the hydrogen gets added across the double or triple bond and converts the unsaturated hydrocarbon into a saturated form of hydrocarbon. This process is called as hydrogenation. This process is used in industry to convert vegetable oil into vanaspati ghee. Which of the following hydrocarbons undergo addition reaction? So for addition reaction, you will have to understand the structure of these before getting there. So C2H6. C2H6 is ethane. C3H8. C3H6. If I put a double bond here, you will see that let's first fill this. Now, based on this double bond, you can tell that this valency is fulfilled and this also needs only one more hydrogen. So it is 1, 2, 3, 4, 5, 6. So you know that the general formula of alkene is that CnH2n. So you know that this is an alkene when you look at it, but I've drawn the structure also for you. Next is C2H2. So we draw C, and then of course for again there's a double bond here. So you know that this would be a triple bond because it is showing that it only has the general formula is CnH2n minus 2, which is that of alkyne. That means it's a triple bond. The last is CH4, which is simple methane. So first you draw structure of all these atoms. You don't have to draw the structure, but it will make it easier for you to understand. If you don't know the structure, you remember the general formula and you see if it is alkane, alkene or alkyne. So as we see here, this is ethine and this is propene. Now we have these molecules and the question is which of these would show addition reaction. For an element to show addition reaction, it needs to have an unsaturated hydrocarbon. So there are only two possibilities for unsaturated hydrocarbons here. One is this and one is this. So the answer is that addition takes place in unsaturated hydrocarbon. Hence C3, H6 and C2H2 are the unsaturated carbons which will show addition reaction. The next question is give a test that can be used to differentiate between saturated and unsaturated hydrocarbons. Now to differentiate between saturated and unsaturated hydrocarbons, we will use the bromine water test. Now bromine water test is a simple test. So whenever there's an unsaturated carbon atom, let's see there's an ongoing series. So R represents an ongoing series. It can be as long as it has to be. And whenever we add bromine to it, what happens is that this double bond breaks and bromine gets added to it. So the color of the brown color of bromine disappears. So this part has decolorization. So the brown color disappears and this is a way for us to know if this is an unsaturated carbon also. So bromine water test in which we add a brown colored liquid which is bromine water. Unsaturated hydrocarbons give addition reaction with bromine. So the color of bromine gets decolorized in this reaction. Whereas if this was a saturated hydrocarbon, then there would be no reaction and the brown color of bromine would remain. So we would be able to identify based on this test. That is all for this portion. Thank you.